Of course, one of the important things we have to do is be able to do word problems. So today we're going to look at a particular type of word problem, usually involving rectangles and solving by factoring. So the first thing we're going to do is translate words into algebra. That's when you see things like more than, less than, double, triple, etc. Then we're going to set it equal to the area, because most of these we're going to be finding area. Then we're going to multiply into the box, the literal rectangle we're drawing. We're going to solve by factoring, like we've been doing. Cross out any negative answers or answers that don't make sense, because we're talking about length and width, so when I get a negative, that doesn't make sense. And make sure, last of all, that you answer the question. Make sure you answer the question. So let's look at the first problem. The length of a rectangle. What do we want to use to represent the length of a rectangle? How about L? L is, what does is mean when we're doing translation problems? It means equals 7 less than the width. So the width we're going to use W, but less than, if you remember from earlier in the year, is a turnaround word. That means I need to switch the things that are on the two sides. Less than is going to be subtraction, and I'm going to switch the sides. So the width is going to come first, and the 7 is going to come second. It's really important that we get that order correct. So let's draw an actual rectangle where that's the case. The length is 7 less than the width. And then we can put the W on the side. We want to have these in terms of the same variables. That's why we keep, if it's in terms of W, we're going to put W on the side. And we're going to multiply those like you're used to doing with a rectangle. W times W is W squared. Negative 7 times W is negative 7W. So what we just found is the area. So we're going to set the inside equal to the area that they gave me, which is 30. And now I'm just going to rewrite that outside my box. W squared minus 7W equals 30. And now it's just a solving by factoring problem. So when we solve by factoring, the first thing we need is for it to be equal to 0. Is it equal to 0 yet? No. So that's going to be my first task. So to get rid of 30, I'm going to subtract 30 from both sides. But 30 is not a like term with what I have. So I'm just going to put it at the end since it's my constant. Do I have a GCF? Always ask if you have a GCF. In this problem, I don't. So I'm going to keep going. And I need some room. I'm going to come up here. So since I have 3 terms and no GCF, I'm going to do X box. A, B, C. My A is 1. My B is negative 7. And my C is negative 30. By the way, if you need help on Xbox, look at one of the other videos that has that, the way we're factoring right now, in more detail. Okay, then we're going to put our first term, W squared, in the first box. We'll put our last term, negative 30, in the last box. We multiply our diagonals, so negative 30 W squared, and negative 30 goes at the top. Then our B from earlier goes at the bottom. And now we ask the question, what two numbers multiply to negative 30 and subtract to negative 7? And those are going to be negative 10 and positive 3. So negative 10x and 3x. Now we need to factor out the GCF of my first row. Whoops, we're using W, sorry. So let's put W's there. W, what times W is W squared W? What times W is negative 10W? Negative 10. And what times W is 3W? 3. 3 times negative 10 does give me negative 30. So my factored form is W minus 10 times W plus 3. And we're solving, so we're going to set that equal to 0. Now, you could have been doing this whole problem in terms of x, but that means at the very end you're going to have to go back and remember which one was width and which one was length. So that's why I like to use L and W. So since I have two things being multiplied equal to 0, once I get to this point, I'm going to separate set equal, and solve. Separate, set equal to 0, and solve. Hopefully we're getting to where we can kind of do part of this in our head. So add 10, w equals 10, and subtract 3, w equals negative 3. Remember, w means width, so does it make sense for me to have a width of negative 3? No. So I have a width of 10, but if I go back to the very beginning, what was my question? The question is, what is the length? So if the width is 10, that means I can find my length a couple ways. I can plug it into my original equation, length equals width minus 7. So length equals 10 minus 7, which is 3. Or I can think that my area is 30, so if my width is 10, that means my length is 3. Any way you want to do that, that's fine. So let's look at number 2. The length of a rectangle is 5 times the width. So the length of a rectangle, what do we want to use for that? L. What does is mean in a word problem? Equals 5 times the width. So what does 5 times the width mean? Just 5w. So let's draw a little rectangle with that. So we have a rectangle, and this time I only have one term on the top, and it's in terms of width, so we'll put width on the side. So what's the area of that rectangle? Just going to give me 5w squared. So that's my area. In the problem, it tells me my area is 45. So if I write the area equal to the number they gave me, 5w squared equals 45. Now it's ready for me to solve by factoring. So to solve by factoring, it needs to be equal to 0. It's not equal to 0, it's equal to 45. So we're going to subtract 45 from both sides, which gives me, since they're not like terms, 5w squared minus 45 equals 0. Once again, we're just going to come up here into this problem. Now, the first thing when I factor is I need to look for a GCF. So is there something that goes into 5w squared and 45? Absolutely. It's going to be a 5. I can't take out a variable since there's not a variable in each box. What times 5 is 5w squared? W squared. What times 5 is negative 45? Negative 9. Write your sides. 5 times w squared minus 9 equals 0. Now, I still have something squared inside, so we want to keep making sure that I am factored all the way. So how many terms do I have? I have 2. Are they perfect squares? Yes. Is there subtraction in the middle? Yep. So if you're in my class, then you know the rap by now. So for everyone else, this is just part of my normal class. So if you've got 2 terms, perfect squares, subtraction in the middle, let's go from there. Put your parentheses, one with a plus, then a subtraction. Yes, you must. Square root of the first. Wiki. Wiki. Square root of the last. Wiki. Wiki. Keep them in order, and you're done fast. I know you're out there doing the difference of squares dance. Alright, so I have it totally factored, and now we are trying to solve, so we're going to separate, set equal to 0, and solve. I got to write really tiny for this one. 5 equals 0, w plus 3 equals 0, w minus 3 equals 0. But does 5 equal 0? No. Then I'm going to get w equals negative 3 once I subtract, and w equals positive 3. Which of those makes sense? Well, it's not the negative because I can't have a negative width. So my width is 3, and then I go back and I reread my actual question, and my actual question asks for the width, so I'm done with that part of the problem. My width is just 3. So you always want to reread. Sometimes you're done, sometimes you're not. Okay, and number 3. The length of a rectangle, once again, let's just use L, means equals, when we're doing translation, length of a rectangle is 1 less than twice the width. So remember, less than, once again, is one of the turnaround words, so I'm going to flip what's on the 2 sides. So less than is going to be subtraction. 1 now needs to go at the end instead of the beginning, and twice the width would be 2w. So let's draw our rectangle with a length of 2w minus 1. Since it's in terms of w, we'll put a w on the side. Multiply to find your areas. 2w times w is 2w squared. Negative 1 times w is negative 1w. That's my area, so I'm going to set it equal to the area they give me, which is 15. And now I'm going to write that part outside my box. So 2w squared minus w equals 15. To solve, I need it to be equal to 0. It's not equal to 0, so we're going to subtract 15 from both sides. That's not a like term, so I can't combine it, which gives me 2w squared minus w minus 15 equals 0. When factoring, the first thing I look for is a GCF. Do I have a GCF? No. So now we go on to how many terms I have. I have 3 terms, so we're going to factor this with Xbox. A, B, C. My A is 2, my B is negative 1, and my C is negative 15. Go ahead and draw your box. First term, first box. Last term, last box. Now we're going to multiply our diagonal, which would give me negative 30w squared. That goes at the top of my x, and I'm just going to do the coefficient, so negative 30. Then our b from earlier goes at the bottom, and now we're looking for the two things that multiply to negative 30 and subtract to negative 1. So that's going to be 6 and 5. One of those is negative, needs to be the negative 6. So negative 6, whoop, w, didn't draw a big enough box, what else is new, and 5w. Now walk it out by factoring. GCF of my first row is 2w. What times 2w is 2w squared? W. What times 2w is negative 6w? Negative 3. What times w is 5w? 5. And check your last box. 5 times negative 3 is negative 15. So we have 2w plus 5 times w minus 3 equals 0. Separate, set equal to 0, and solve. So we're going to get 2w equals negative 5, and w equals negative 5 over 2, and then w equals 3. Well, I can't have the width be equal to a negative, so it's not going to be my first answer. My width is going to be 3, but the question, if we go back to the beginning, is what is the length? So I'm just going to substitute into the first thing we got, which was 2w minus 1 is my length. So L equals 2 times 3 minus 1. 2 times 3 is 6, minus 1 is 5. And you could double check my length is 5, my width is 3, so that does give me an area of 15, which was the other piece of information given to me. So always make sure that you answer the actual question that's being asked.